The reason that we're here is to work with farmers and to work with U.S. Department of Agriculture to improve agricultural land. And when I say improve it, what I mean is we can use the tools that we have with the drones, the sensors, and the resultant data that comes from that to help us figure out the best use of a piece of ground. For example, what we're flying today is pretty much useless ground right now in terms of the invasive species that have come in and in terms of the useless trees that have come in. And what the farmer wants to do is, number one, stop some erosion. Number two, he wants better wildlife habitat. And number three, he has cattle in this area and the cattle have very little to eat. If we can change all of that, the farmer wins and the environment wins. Now, how does a drone come into play with this? Well, that drone is about 1/10 the cost of surveying this piece of ground versus either manned aircraft or putting people out there and surveying. Several months ago, we flew a property and we got imagery on over 1,000 acres. And it took us 1 day to get that 1,000 acres. The customer told us that if they would have had a field survey team go out there and do it to that resolution, it would have taken 2 teams of surveyors the entire summer. And we got that data in 1 day. Today, for this particular customer, because of their mission, we're running LiDAR. If you just took a normal picture from the air, you wouldn't be able to see where the ground is. It would just show the top of the trees. Whereas LiDAR shows the top of the trees, but then the imagery continues down through there, can measure how many board feet, how much marketable timber is actually there, and can see the exact elevation of the ground. In the past, we would have people actually walk this cornfield once every week or once every 2 weeks. Now what we can do is we can take a drone and fly over it with a smart sensor that can detect drought. With the GIS software that's available today, all the imagery that we're talking about can be geo-referenced. Geo-reference means with respect to those control points that we put out, where we know exactly the latitude and longitude of each one of those, and we know exactly the elevation of each one of those. We can take the LiDAR imagery and layer it on top of any other layers that we have. So we have topography data, we can have the LiDAR data, we can have the cropping data, we can have land ownership data, we can have digital ortho. We can take all of those layers of data and layer them on top of each other, and because it's all geo-referenced, they're all meaningful. The cool thing with using drones and unmanned vehicles such as this is the accuracy and the resolution and the preciseness of the data that you can get from this. We at Cherokee have the ability to go find the right drone and the right sensor for the particular job that our customer wants. And we right now have contracts nationwide, and we can provide coverage nationwide with exactly the right vehicle and the right sensor to accomplish the user's objective. We have a very good solution that can be matched with the exact need of the customer. It gives them, in 100% of the cases, more knowledge to make smarter decisions. It gives them more wisdom in their ability to plan tomorrow.